Hello everyone and welcome back to the Bodhi Academy. In today's PYQ series, we are going to solve chapter number 2, Acid, Bases and Salt of class 10, subject Science. So let's quickly start with our first question. For the first question, we have copper sulfate crystals contain water of crystallization. Under this statement, we have two sub-questions. First one is that what is the molecular formula of hydrated copper sulfate? So they are asking molecular formula of hydrated copper sulfate. Okay, so hydrated means there is some kind of water molecules that are present. First, let's quickly write down copper sulfate. So it is CuSO4 dot hydrated means for hydrated copper sulfate we have 5H2O. So this is copper sulfate pentahydrated. Okay, so we call it CuSO4.5H2O. Under the same subtopic, we have another question. How is plaster of Paris prepared? So second question is about plaster of Paris. Now plaster of Paris is prepared by heating gypsum. Now this gypsum is nothing but it is CuSO4.2H2O. Dihydrated molecule of copper sulfate. So we heat this gypsum, that is CuSO4.2H2O, at 373 Kelvin. So when you heat it, this water molecule which are there, these two water molecules which are there, they are reduced to CuSO4.5H2O, and this is nothing but a plaster of Paris. Moving to the next question, we have write the chemical name and the formula of bleaching powder. So we have bleaching powder. We have to write its chemical name and also its chemical formula. Now we know bleaching powder is nothing but calcium oxychloride. Okay, and its chemical formula is CaOCl3, calcium oxychloride. So bleaching powder, its chemical name is calcium oxychloride and its formula is calcium OCl3. Next we have to state one use of bleaching powder. So we have to state any one use of bleaching powder. Okay, so here one major use of bleaching powder is that it is used as a disinfectant for distilled water. Okay, and second is that we know it is used to remove out any stains that are there on any cloth or any material. So it is used to remove stains from any material. So these are the two major uses of bleaching powder. One is that it is used as a disinfectant in distilled water, and second, it is used to remove stains from any material. Moving to the third question, we have complete the following reaction. So they have given us acid plus base gives us dash plus dash. Okay, so here we know a reaction between an acid and a base. Firstly, it is known as a neutralization reaction. Why is it known as a neutralization reaction? Because further, if we see over here, one of our products is a salt and second is a water molecule that we get. So what we see is that the acid and the base which were there, both are being neutralized to salt and water. So that is the reason we call it a neutralization reaction. Next question is, we have to list one practical applications of neutralization reaction. So one practical application, okay, let's talk about whenever we have acidity in our stomach, we consider it that there is excess generation of HCl, that is the stomach acid that is present. So in that case, we always take up an antacid. Now this antacid which is there, this is nothing but a base. So what happens when there is excess of acid and there is base also? So it is getting neutralized to a salt. So antacids are used in our stomach, or antacids are used generally to neutralize the excess effect of any acid. So that is one major practical application of this neutralization reaction. Let's move to the fourth question. We have If a few drops of concentrated acid accidentally spill over the hand of a student, what will you do to help the student? So say there is a accidental situation that has occurred and there is spillage of acid that has happened. So in this case, what is the first thing we need to do is that we need to wash the student's hand with plenty of water. We need to wash off the student's hand with plenty of water so that whatever residual acid is left onto his or her hand, that will be washed off. Second thing we can do is we can use baking soda. Okay, baking soda is nothing but NaHCO3, that is sodium bicarbonate. So baking soda which is there is a base and the student has had a reaction with the acid. So when you use a base onto an acid, it will neutralize the effect of that acid which is fallen onto the student's hand. So therefore, whenever there is such accidents, we need to remember that we need to, in case of an acid spillage, we need to use a base. That is, one common base is the baking soda. Next we have, how do we identify basic and acidic solutions with the help of methyl orange. Now let's talk about the acidic solution. Say we have methyl orange. Now this is basically just orange in color. So if we test it for a solution which is acidic, it will change its color to red color. Okay, and if we use it for a basic solution, it will change its color to yellow. So if we are using methyl orange to check which one is acidic or basic, so if we randomly pick up a solution and if it is acidic, the solution will turn to red on adding methyl orange, and if it is basic, on adding methyl orange, it will turn to yellow color. Now let's move to the fifth question. We have, a white powder is used by doctors to support fractured bones. So this white powder is nothing but a plaster of Paris. So under this statement, we have first question, how is it prepared? So this we have already learned that we have gypsum, that is CuSO4.2H2O, which is heated at 373 Kelvin, okay, and that gives us CuSO4.12H2O, that is a plaster of Paris. So second question under this statement is, when this white mass is mixed with water, a hard solid mass is obtained. Write a balanced chemical equation for the change. So they are saying when we take this CuSO4.12H2O, that is our plaster of Paris. So we mix some water to it, so then it solidifies and we put it onto the fractured area. So in that case, we take this plus we add say 1.5 molecule of H2O. It gives us CuSO4.2H2O, and this is nothing but a gypsum. So we are taking CuSO4.12H2O, that is water, then we are adding 1.5 molecule of H2O, and then it gives us CuSO4.2H2O, that is gypsum. Moving to the sixth question, we have two give reasons questions. So first one is that baking soda is used as an antacid. So we already know baking soda, it is nothing but NaHCO3, that is sodium bicarbonate, and we know that this is a base. It is basic in nature. So whenever there is excess of acid in our stomach, okay, so there is excess of acid and the acid is say HCl, that is the acid that is present in the stomach. So whenever there is excess of this acid, we call it as acidity. So to neutralize this acidity, we take a base, and that base is nothing but a baking soda. So that is NaHCO3. So this baking soda which is there, it has a aim to neutralize the excess of acid that is present into our body. So that is why baking soda is used as an antacid. Second is that, what is the best way to prevent tooth decay? So in that, first we have is to prevent excess of sugar, or you can just avoid foods which have excess of sugar. And second is that it is preferred to use a fluoride toothpaste. So first is to prevent excess of sugar and second is to use a toothpaste that contains this fluoride molecules. Moving to the seventh question, we have milk of magnesia and orange juice are taken in two tubes, tube A and tube B respectively. In which tube will the pH be 5? So first we have to tell in which tube pH will be equal to 5. So let's evaluate. First we have milk of magnesia and second we have orange juice. Okay, if we don't know about milk of magnesia, let's first talk about orange juice. We know orange juice has ascorbic acid. So when you hear the term acid itself, we know that this is going to be acidic in nature. Now let's talk about the pH scale. Say we are starting from 1 to, so say this is our pH scale. In this from 1 to 6 or 1 to 5, let's say we consider it to be acidic. 6 to 7 we consider it to be neutral. And from 8 to 14 say it is basic. So if orange juice has ascorbic acid, that is acidic in nature, definitely its pH is going to be around in this range. So that is 1 to 5. So now the pH that they have given is 5. So it is acidic in nature. So we can say that the tube B will have a pH of 5. Next is that what change in litmus paper will you see in the tube? So for this one, if we take red litmus paper, it will remain as red itself, okay, because it is acidic. Second, if you take a blue litmus paper, this blue litmus paper will turn to red and this will indicate the presence of acid. Let's move to the eighth question. We have, you are given two solutions A and B. The pH of solution A is 5 and that of B is 11. So we have solution A and we have solution B. Okay. In this they are saying the pH equals to 5 and here the pH equals to 11. Now the first question is, which solution is acidic in nature? So talking about the acid, we have already discussed that till 1 to 5 we consider it to be acidic. So if the pH is 5 over here, we can say that solution A is acidic, and obviously solution B, that is at around 11, that falls under basic category. So solution B is basic. Next question is, name the solution that has more of OH plus ions. Now let's talk about OH plus ions and H plus ions. OH plus ions which are there, they indicate they are actually bases, okay, and H plus which is there, it is acids. So whenever there is more of H plus ions, we call it as acidic solutions, and whenever there is presence of more of OH ions, we call them as basic solutions. Now in this case, which of them are going to have more of OH plus ions? So obviously the one which is more basic will have more of OH plus ions. So in that case, solution B is going to have more of OH plus ions, whereas solution A will have more of H plus ions. Next question we have, baking soda is used in the preparation of baking powder. What is added to baking soda to prepare baking powder? So we know that from baking soda we are preparing the baking powder. Now what is one thing that is being added to baking soda that so as to we get the baking powder? So over here we add something known as tartaric acid. So when you add this tartaric acid to baking soda, you end up getting the baking powder. Next question is that baking soda is applied to the area after a bee stings. Why? So we know whenever there is a bee sting, this bee it releases an acid, that is the formic acid. Now whenever there is a release of acid, we know only one thing can neutralize it, that is a base. So in this case, to neutralize this formic acid, we use a base, and that is none other than the baking soda. So this is also one application of baking soda. So why do we add baking soda whenever we have a bee sting? That is to neutralize the acid, that is the formic acid that is released during this bee sting. Moving to the last question, we have a metal carbonate X and a metal hydrogen carbonate on reacting with acid gives a gas that turns lime water milky. So first question is identify and write these compounds X and Y. So our X is nothing but metal carbonate and our Y is metal hydrogen carbonate. So in this case, we consider this to be sodium carbonate, and the metal hydrogen carbonate that is there, that is sodium HCO3. So this is our respective X and Y. So this is our X and this is our Y. Now second question is that which gas is released in this reaction? So whenever there is a reaction between this, that is NaCO3 plus NaHCO3, it gives a lime water solution. So why is that? That lime water solution turns out to be milky. Why is that? Because whenever this reaction occurs, there is a release of CO2, that is carbon dioxide, and this carbon dioxide turns the lime water milky. So whenever there is a reaction between a metal carbonate and a metal hydrogen carbonate, there is release of carbon dioxide gas that occurs, and this is the reason that the lime water which is there, it turns out to be milky. So that was it for today's video. I hope you have understood well from this PYQs. We hope to see you again. Please don't forget to like, share and subscribe to the Bodhi Academy.